Good morning everyone. Today we are going to start chapter called acid and base, and this I am teaching from Selena's publication. So here we'll start with the acid and base. First of all, how will you differentiate between acid and a base? Acids are usually very sour in taste, bases are soapy in touch, and they are very bitter in taste. Okay, and salts are formed by the combination of acid and base. And in order to differentiate between acid and base, we have an indicator where we see a sharp change in their color, okay, and in the nature of the solution. So here comes the scientist called the Lavoisier and Davy, who studied the term called acid, base and salt on the specific lines. That means acids will have compulsorily, they will have hydrogen ion present in them, and all the bases will have either metallic oxide O2 minus will be present, or metallic hydroxide would be present, or they will have ammonia solution. They all will be basic in nature. For example, like copper oxide, sodium hydroxide, ammonium hydroxide, these are what? These are your bases, because these contain oxide, this will contain hydroxide, and ammonium hydroxide itself contains ammonium into it. Okay, so they all come into the category of bases. The word acid is actually derived from the Latin word which is acidus, meaning sour, and anything that is sour in taste in the food is due to the acid they contain. Okay, and basically we have two types of acid. One is organic acid, the other is inorganic acid. These all are your organic acid which is occurring in the nature, and you can see that acetic acid contains vinegar. Vinegar contains acetic acid. Citrus fruit, all the khatta fruits will have citric acid. Rancid butter will have butyric acid in it. Gastric juice contains hydrochloric acid. Sting of bees and ants contains formic acid. Sour milk and curd contains lactic acid. Apple contains malic acid. Olive oil contains oleic acid. Tomatoes contain oxalic acid. Fats contain stearic acid. Grapes, tamarind, apple contain tartaric acid. Urine contains uric acid. Okay, at the same time, how you can define acids? So acid can be defined as anything which can release H plus ion and they form hydronium ion are the acids. That means in all the acids you will find hydrogen is common. For example, you see H2SO4 contains hydrogen and it releases hydronium ion. Nitric acid contains H hydrogen. Acid contains hydrogen. Although acetic acid is a weak acid, but it does contain hydrogen. Okay, in general we can say that all the acids will have hydrogen in it. Next we have the classification of acids. Now see, classification of acids is into on the base of their sources. First we have the organic acid. All the organic acids are the one, these are the plant's derivative. They are obtained from the plants like oxalic acid, acetic acid, formic acid, and these are usually your weak acid and they do not ionize completely in the solution, and therefore they contain ions as well as molecules. Okay, and then we have inorganic acid. These are the acids obtained from the minerals and known as inorganic acid, and they do not contain carbon into it. Okay, but carbonic acid is one of the case where you see carbon is present, that is H2CO3. Okay, now what are the examples of inorganic acid? Hydrogen chloride, H2SO4, nitric acid. These all are strong acids as they ionize completely in the solution, producing a high concentration of hydronium ion. Then we have carbonic acid, is a weak mineral acid. You should keep this in your mind because it contains ions and molecules together. It turns blue litmus paper pink. It is non-corrosive, not harmful, and it is present in the soft drinks. Now the acid which contain oxygen into it, these are called oxyacid. For example, nitric acid, H2SO4. What is common in them? Presence of oxygen and the hydrogen. In hydroacid you will find hydrogen and non-metallic element present, but they will not contain oxygen. For example, HCl, HBr. There is hydrogen but there is no oxygen, that means it is a hydroacid. Now depending upon the basicity we have the classification, that is monobasic acid. Matlab ki if you dissolve this acid in water, you will see one hydrogen is eliminated and it is forming hydronium ion and chloride is out. Similarly, all the acids containing only one hydrogen atom, these are your monobasic acid. Okay. Now see, it is said that in this box ki basicity does not depend on the number of hydrogen atoms in one molecule of that acid. Rather, it depends upon the number of ionizable hydrogen atoms. Okay, it means what? Ki acetic acid is also coming into the category of monobasic acid because it releases only one hydrogen ion. Okay, it has only one ionizable hydrogen ion. That is why it is categorized as monobasic acid. Then we have a dibasic acid because it releases two hydrogen ion per molecule, and therefore it is a dibasic acid. Here we have the example: sulfuric acid, oxalic acid, sulfurous acid, carbonic acid. Okay. Then you see the dibasic acids have two replaceable hydrogen ions, and therefore they form one acid salt and one normal salt. That means if you dissolve this dibasic acid in water, in the base, you will see acid salt formed and water is released. Now if you take the double mole of the sodium hydroxide dissolving into the sulfuric acid, you will see there is a formation of sodium sulfate, which is your normal salt. Now see, what is acid salt and normal salt? This we will learn in the category of salt. As of now you understand this. Alright, now see, here is one very popular question by the Icse, that is S3PO3 is a dibasic acid. Why? But although it contains 3 hydrogen ion. Now see, it is a dibasic acid because when you see the structure, one hydrogen is directly attached, two hydrogens are linked with the oxygen, and thereby they are connected with the central metal atom of phosphorus. And why it is a dibasic acid? Because now see, among oxygen and hydrogen, oxygen is highly electronegative. It will pull all the electrons of the hydrogen towards itself, and this hydrogen can easily be released. And same occurs in case of this OH. But regard to this hydrogen, which is directly linked with the phosphorus, cannot be removed so easily. That is why this hydrogen becomes not replaceable. But whereas this OH, hydrogen attached with the OH, is replaceable. That is why it is a dibasic acid and not a tribasic acid. Then we have tribasic acid. Okay, you can see the examples: phosphoric and the citric acid. Okay, and you will see that when the tribasic acid undergoes, they contain two different types of acid. Okay, that is, they contain one acid salt and the other one normal salt. Okay, so this is how the acids are being classified. Now have a look. This is a sodium hydroxide reacting with phosphoric acid. It is forming sodium hydrogen phosphate. This is your acid salt and this is your normal salt. So it is forming one normal salt and one acid salt, the other normal salt. And here you see the silicic acid, that is H4SiO4, has basicity 4 because it contains 4 hydrogen atoms.